Okay, howdy everybody. We're going to be graphing Venn diagrams. If you're unfamiliar with how to graph Venn diagrams, I recommend you see the video Venn Diagrams Part 1. That'll show you the 4 different statements. This will focus on how to do that in the full Venn diagram. So this is Venn Diagrams Part 2. And there's 3 steps to graphing Venn diagrams. The first step is graph the universal premise. So if you've got 2 universal premises, it doesn't matter which premise you graph first. If you've got 2 particular premises, it doesn't matter which one you graph first. But if you have one universal and one particular, make sure that you graph that one first. The second step is graph the other premise, right? So in every categorical statement, you're going to have 2 premises. So this is the universal one first. This is the second one, whichever one's left over. If they're both universal or both particular, again, the order doesn't matter. And then the final question is, a big mistake people make is they try to graph the conclusion. Do not do that. Just ask yourself the question, is the conclusion represented? If the answer is yes, then you got a valid argument. If the answer is no, then you got an invalid argument. Take some time to review these steps if they're confusing, but I think the best way to understand them is to see them in practice. So we got a couple of examples here. First example is right here. Some frogs are dogs, all frogs are silly things, so some silly things are dogs. So again, step 1 says graph the universal premise first. So in this case, it's not my first line that I graph first, it's my second line, because it's universal. All frogs are silly things. So I label my circles, so I'll make this one frogs, this one dogs, and this one silly things. So I'm looking only at frogs, right? Frogs, some frogs are dogs, right? Sorry, I don't look at that because that's the particular one. I look at the universal one first. All frogs are silly things. So I'm looking at the frog circle and the silly things, right? And as I know from how to graph an A statement, all frogs are silly things. It's an A statement, so I shade the subject just like that every single time. So step 1 is complete. I've shaded that. If that's confusing, go back to part 1. Now, the next step I do is just graph the other premise. So another premise is some frogs are dogs. So I'm only looking at the frogs and dogs circle. It's particular, right? It's an I statement, so I put the X in the middle. Some frogs are dogs. It's going to go in here somewhere. This part has already been shaded out, so that only leaves me to put the X right there in the center, because that's the only place between the dog and the frog circle. So the final question I have to ask myself is the conclusion represented? Are some silly things dogs? Well, I look where the silly things circle is, and I look where the dog circle. Is there any overlap? Absolutely. Right there. There's an X that is in the silly things circle and in the dog circle. It's also in the frog circle, but that doesn't matter. Only thing that matters is the conclusion is represented. So this is this already represented? The step 3, the answer is yes, so this is valid. Moving on to the next example, right? The exact same process. Graph the universal premise first. In this case, we have a mismatch, so I have to graph the second one first. All animals are teachers. So I label my circle, that's T, that's animals, right? And this one's cats. So all teachers are cats. All animals are teachers. All animals are teachers. I'm going to look at my animal and my teacher, right? So I graph, shade the animal, our teachers, shade all that business in. Then I look at my other step 2, right? Some teachers are cats. I put the X in between the teacher and the cat circle. Should go right in there like an I statement, but wait, I don't know if it should go here or here. So I'm forced to put an X in the middle. Trick that Menzel taught us, if an X is ever on the line, it's automatically invalid. Automatically invalid. So this one is invalid. But to proceed to step 3, just in case, some animals are cats. Well, I don't know. Is that X here or is it here? Because if the X was over here, it would be invalid. If the X was here, it would be valid, but I don't know which one, so I can't guess, so I have to make this one invalid. So these 2 examples show the difference between a valid and an invalid argument. There's a lot of different combinations. There's E's and O's, but they're all essentially, it's the exact same process. If you know how to graph one statement, then you know how to graph all the statements. If this is confusing, I highly recommend you start with Venn Diagrams Part 1 to become comfortable with all the different shading, and then work through these examples a couple of times along with the video. If you have any questions, shoot me an email. Thanks, guys. Have a good day.